Good morning, good morning, good morning. Welcome, everybody. For those of you who don't know, I'm Sarah Paris, Inspire Account Manager at the Thames Valley Chamber of Commerce. Some of you do know me already. Good morning, Yola. I can see you. If I can ask you to keep your microphones muted for the duration of this. And I'm really sorry that this isn't being held. Normally, we would do this over a fabulous lunch or dinner with a glass of wine in our hand. That's clearly not possible at the moment, but fingers crossed in the not too distant future. And what a fortnight of news. And no, I'm not talking about that interview. I'm talking about the Mars rover, or the rover landing on Mars, I should say, and the fantastic work that's happening. We won't mention NASA, will we, Nick? The fantastic work that's happening there, but I believe there is a bit of collaboration with the European Space Agency going on there. Being a bit of a frustrated scientist, I just wanted to kind of say how this project came about. The space sector has fascinated me, scared me, and puzzled me in equal measure, I suppose, to an extent, because there must be a huge amount of resource, and I'm sure Nick will cover this, a huge amount of resource, both financially and from a manufacturing point of view, that goes into this. But being a bit of an eco warrior, it didn't kind of sit comfortably with my sort of green credentials, for want of a better word. So I enlisted the help of Dr. Nick Appleyard from the European Space Agency, who I know is equally passionate about saving the planet, to explain why investment in the sector is so important for modern life on Earth, and what they're doing around sustainability, and why the sector is a good place to invest in, from a governmental perspective, I suppose, and indeed as individuals, and how it impacts us and the SME sector in particular. I'd ask you all to put questions in the chat box, and Nick will either answer them live or at the end, depending on how he's feeling and what the questions are. Keep them clean, people. Also, you know, if you hear something that's relevant to one of your clients, please do direct them to our library, because this meeting will be recorded, although you can speak freely. We have a very clever editor behind the scenes, probably giggling away now, who can cut out anything that's either tricky or you know, of a sensitive nature. But you can direct people to our library, you know, share the link thereafter. It goes on a YouTube channel. So without further ado, because I've probably spoken enough and spoken nonsense, I'm going to hand over to Dr. Nick Appleyard with a very complicated title, I have to say, which he'll explain, I'm sure, from the European Space Agency. Welcome, Nick. Thank you.
Well, thanks, Sarah. Now let me get my screen shared. Do you have the right version?
Yes, we do.
Yes, okay, you're seeing the full version. Okay, that's me. So, hello, I'm Nick Appleyard. So I'm the head of space solutions at ESA, and we have our base over in Harwell, so we come within the catchment of Thames Valley. I've been with the agency for 4.5 years now. And I'm responsible, really, and space solutions is how we term our outreach into the non-space community. So how is space helpful to people who are not themselves part of the space industry, particularly businesses and people who can make use of it. So that's my gig. I get to hang out with astronauts from time to time. This photo taken in the lobby of our offices on the Harwell campus. Me and my friend Tim, actually me a cardboard cutout of my friend Tim, but we do meet from time to time. And I think last time I saw him, we went to see Shaun the Sheep at the Leicester Odeon. I guess ESA had some involvement in that one. My last job, say I've been with ESA 4 years or so. My last job was UK government, actually Innovate UK, and I was the digital economy lead there, and also the Whitehall liaison. So I got to hang out with other parts of the space community in that case, and creative industries, and the people making Star Wars was kind of one example of that. So I come from that environment of innovation in digital economy, bringing that now into the space industry, and the reason that has a synergy and has a connection. These are all the different areas that ESA is active in, which is pretty much soup to nuts service to all different aspects of space. All parts of this now are starting to be transformed by the involvement of businesses more. It used to be that to get into space at all, you needed to have budgets of the hundreds of millions minimum up into the billions, which meant you had to be a government. And so nobody else in the 50s, 60s, 70s, nobody other than governments could get into the game at all. That is no longer the case, right? So the technology has now got a 50-odd year heritage, which means it's a lot cheaper, a lot easier to use. You don't need to be anywhere near as expert, and the cost has come down enormously. So now we have people who are building small satellites, nano satellites, size of a loaf of bread, shoebox kind of size satellites, for a few million of your favorite currency units, including launching them into space. And you'll have heard about rocket companies now who are offering commercial payload space to get your things into orbit. So now, if it's only a few million, now it's startup companies, it's seed capital, and pretty much everybody can play. So we have all kinds of people now launching satellites into Earth orbit, with cameras on, with antennas on, broadcasting their own signals or making their own measurements, and getting just a little bit of the data economy, which is proprietary to them, which they can then make use of back on Earth. So this is now becoming part of the commercial digital ecosystem, which was never the case before. So space used to be a government endeavor, scientific and exploration endeavor. Now it's very much a commercial piece of infrastructure. So that column of applications which you see there in green is where we're really talking about satellites, and that's most of what I'll be talking about today. We have satellite manufacturing capabilities. So satellites just down the road from us have been pioneers in small satellites and towards driving this cost down and making this more accessible. We have different modalities, if you will, different kinds of satellites. So there's the telecommunications ones, which allow you to move signals from one side of the Earth to the other in minimum time. There's the sat-nav geolocation satellites, which allow you to pinpoint where a receiver is anywhere on the surface of the planet. And there's the Earth observation, the imaging and measurement satellites, which are used very much in things like weather, in monitoring climate, in land use, oceans, and this kind of thing. So those three kinds of satellites together, each with their own capabilities, each are making contribution to these systems. But equally, this commercialization I'm talking about is getting into all of these other vertical columns there as well. And yesterday was my day with the International Space Station guys, who came to my team and said, okay, we've got all these labs on the space station. We got all these astronauts who can operate scientific experiments and things. What we really want are some businesses to be using that. Can you help us with the marketing effort and the outreach into the customer communities? Go and find us some users for the labs on the space station. So, because I get to do the commercial interface for this. So that's my cool day in the week is hanging out with those guys. Most of the time I'm hanging out with the non-space industries on the ground. So this is where we are physically. I'm sure a lot of you go on and off the Harwell campus for your own day-to-day. So the building that if you come in through the gateway, which has the big satellite dish, the first building on your left with the flags is our office building. Before you go further down the road and you see the synchrotron and Medical Research Council and the Vaccines Manufacturing Centre down at the back there. And there's actually quite a cluster of space activity on the campus. So it really is a national centre, that cluster. So we're surrounded by the companies that we work with, and also by kind of government bodies like the Satellite Applications Catapult and SGFC's facilities, Rutherford Appleton Lab. So, but that's our building, the one with all the flags. And it's one flag for each of the countries who are members of the European Space Agency. Their flags sit across the bottom of my slide decks there, 22 of them, and another 3 who are kind of affiliated with us. And you might recognise Canada there as being our non-European friends. But you know what? They had a choice. They could look south, or they could look east. They decided they'd rather make friends with us to their east. So the way it works is we're an intergovernmental organisation. We take funding contributions from each of those national governments, pool them into a common pot, and then we use that money across the industry across all of those countries, so essentially across all of Europe, pro rata with what contribution they've made. And in the stuff that I deal with, which is the commercialisation activity, very much the largest contributor is UK government. UK is going after the economic benefits from space. So somewhere between a third, 40% of the budgets which are in my pooled pot are UK budgets, and then I have to spend them with UK industry. Sorry, going the wrong way. So that's the European Centre for Space Applications and Telecommunications, and it's kind of a joint venture between ESA and UK government. My boss, Elodie Viau, then is responsible for those two areas, space applications and telecommunications, and we headquarter that from the UK, but we cover all of Europe from the UK. And the space applications part is my responsibility in there. So a big chunk of what happens in that building is my team, and another part of my team sits in the Netherlands. Okay, so I'd say this is largely about satellites. Those satellites are there looking back down again, and they're there to communicate with things back on Earth. And that's really the point of it from an economic perspective, is what can you do on Earth which is enabled by the existence and operation of these satellites. And really there's a lot, right? We go around industry by industry, saying, how could you use the telecommunications, the location, and the Earth observation capabilities in each sector. And it's pretty much no sector that we've looked at where we've come back with an empty playbook. Some there's a very strong response. So anything to do with transport, air, sea, land, rail. Generally the rails go on land, but anything to do with moving vehicles. If you rely on terrestrial communications, they go in and out of coverage all the time. So, but if you have a satellite link, it doesn't go out of coverage. So as long as you can see the sky, your satellite link will still be there. So if you are in aviation, or if you're in maritime industry, or even if you're just driving logistics trucks around the landscape, having a satellite link gives you access to a continuity of service which you can't get any other way. And as we increasingly digitize those transport modes and automate them, we're going to be more and more reliant on satellites for that. Equally, anything which is in a kind of a remote location where there isn't ground coverage of telecommunications, then again, you rely more and more on satellites. So agriculture is a big use area for us. Forestry, anything in the mountains. So those kind of areas tend to be where we find most of our customers. But equally in cities, right? You go around in London, you get not spots, places where you just can't get a signal, right? So having a rollover capability onto a satellite signal gives you more resilience in your services. So all of this then somehow comes together around the customer needs. So we're trying to put together things which serve a commercial system. And if you don't get your customer side and your demand side right, then it doesn't matter how good your technology is, if only somebody had bought it, because they didn't buy it. So we tend to argue from the customer end as much as we can. How do they want to use the connectivity and the other technology and capabilities that we have? And and unless we're talking to our funders and the governments, in which case we argue it the other way and we say, look at all the great benefits you're getting from this. You're getting job creation, you're getting revenues, you're getting exports, and you're strengthening your own kind of industrial strategy contributions. If you argue back from the customer end back towards the supplier end, that gives you some insight into what we should be building in terms of new satellite capabilities in order to serve those needs. And you see at the left side of the slide there some of the things which we have prioritized as a result of that. 5G is coming on the terrestrial telecommunications. As a result of that, we want satellites to be part of that story, and so we're developing satellite 5G. Security, safety, critical systems are absolutely pervasive. I talked about self-driving cars and things. You want them to be cyber secure, and you want the connectivity to be resilient and reliable, because it's a safety critical system. And there are many more examples like that in the infrastructures around us. And then from a kind of a technical development point of view, we're starting a migration across from communicating with the satellites by microwave and radio signals towards communicating by lasers. Higher bandwidth, more directional, more private, and generally more flexible. So there's a lot of technical development going on around optical communication links, laser communication links. To the point now where we're starting to talk about quantum secure communication for quantum key exchange between banks. This has been kind of demonstrated on the ground. The bank signature is very useful because it allows them to hand their encryption keys off to each other in a secure way. But the range of doing that over an optic fiber is only about 100 kilometers. Beyond that, the signal degrades. But if you do it by satellite, you can go up, round, and back down again, and you've only gone through 20 kilometers of atmosphere in doing that. So you can take those signals from one side to another. So this is the kind of technology we're working on around this. Telecommunications, big focus for us, as I said, out of the UK. The kind of user groups that we're serving with that, then, kind of starting from the top left, there's the consumer applications of just having high bandwidth communications, with pervasive coverage, and the kind of user equipment that you can attach to that. And we have activities in all of those end use markets which are listed there. Down to the bottom left, more about industrial and system installations, Internet of Things, but then how do you get the signals out of your Internet of Things system and back to where you need to do the analysis and the control from. Talked a lot about vehicles already, so I won't dwell too much on that one again. But on the top right, a lot of stuff about maintaining connection to vehicles, and then particularly when we're talking about emergency services and safety critical systems of that kind, disaster management, putting things together with whatever your disaster response might be. Also, all of these things can be served by satellite communications, and these are all the kind of users that we're reaching out to. So those of you who are in any of those sectors, I'd be very interested to talk to you about what your customer needs are. This is kind of how we're breaking it down at the moment. In terms of the thematic content of what we're talking about, the connectivity, the security I've talked about, also the digital transformation. As we bring more digital technology in, it disrupts what's happening in other industries, and satellites are playing a role within that. Get on to Sarah's favorite topic, which is the environmental impact of what we're doing. Right? You can use the insight that you have from satellites and your ability to automate and control systems better to actually improve the environmental footprint of what's happening on the ground. And then, as I mentioned with my friends on the space station, this commercialization of what's happening in space itself and the building of an industry, a commercial industry of people operating in space. The tools that we have in order to do that are, under my kind of management, we have a network of business incubators. So we have dealt with very many startups around Europe, and there's one of those incubators on the Harwell campus. So that's the kind of starting point. And then as those companies grow and build up into SMEs and look for markets, develop their products, we try to offer support to them all the way through. And there's funding available, particularly for product development along that pathway. But also we have a big network of partners and other organisations we work with to make sure that any company who is not just a space company, but a space using company and an affiliate of a space company is fully supported. Talk about this network of business incubators. If you put them on a map, put a dot on the map everywhere where we have an office, then actually it's getting to be quite a satisfyingly spotty map. And you can see quite a few of those things in the UK. So the incubators, the three blue lines joined, blue points joined by line up the spine there. We have 3 sites for the incubators in Harwell campus, in Daresbury, and in Edinburgh. And then the white spots there is our business development people. We call them ambassadors. So they're out there working the customer communities on a regional basis and making sure that our connection and our message is getting out. And we also work with the private finance, because it doesn't matter how big and how expert your own organisation is, there's always more resources outside it and more experts outside it. We're particularly interested in making sure that when we get involved in kickstarting or pump priming a company, they're not then completely dependent on us for their entire future. So we need the private finance to be coming in and taking over responsibility for keeping those companies afloat. So we have partnerships with, in the UK, with London Stock Exchange, very useful partnership, and they give us some very nice meeting rooms to use from time to time to do investor pitch meetings and this kind of stuff. Right, now on to the second half of what I wanted to talk to you about, which is the purpose and the impact of all of this. Because it's not sufficient just to be developing commercial systems. I think we need to be developing them with a purpose and with an objective in mind. We are, I say, an intergovernmental, but essentially we're a public sector agency. We should be investing on behalf of the public benefit, and not just in order to create private profit. If it were only about private profit, then the private investors could take care of it entirely. But with our help in de-risking it, we can do that much more, and we can direct a little bit of that investment towards more impactful outcomes. I was very privileged to be involved in an economic study about 4 or 5 years back with the big innovation centre in London. So this is economists like Will Hutton, Andy Haldane, who's now at Bank of England, but also C-level people from Kingfisher, Legal & General, some of the big FTSE companies, and they were kind of coming together around this agenda of a purposeful company, to say a company which is clear about what it is trying to achieve, other than just shareholder value, but in addition to shareholder value, is actually a more successful company, because everybody's minds are focused on the job. They all know why they're coming into work in the morning. Now, there were a lot of people around the table who then said, okay, well, let's focus on the shareholders and the boards and the motivation of those people. I took it in a different direction, actually, for myself. But what about the staff? What about the customers? Equally, they're aligned. If you have a purposeful company, they know who they're working with. And that gives everybody a motivation to all pull in the same direction. It's very powerful when you get that right, and you get a company which has a drive around it. Just a little aside, a little plug for my wife's business, if I could just take your indulgence of this a little bit. My wife equally kind of motivated around these things. She herself is a BBC wildlife producer, or has been. Set up a spin-up company now to do this, which is to talk to householders about the impact you can make on an individual level around sustainability. So each of us can make our own decisions about our transport, our food, our energy, our clothes, all of these other things that which are within our spending power. And you can really build up from an individual level to have an impact on the footprint that you have, and you can make sure that you're doing this in an ethical way. So this is kind of going on one side, and then on the other side, I'm kind of my day job. I'm working at a corporate level with companies, trying to say, well, what can you do if you are a company who is active in a marketplace, and trying to divide out this, if you will, on the horizontal axis. What's your profitability? Yes, you put euros in. We talk in euros. It's the European Space Agency. Even though I'm British, working in Britain, we're still talking euros. But you put euros in, and you take more euros out, then you're a business. Congratulations, right? You're profitable. But what about this other axis? So, what about the social impact that you're having? What about the environmental impact? What about the new knowledge that you're creating? All of these other benefits which are less monetizable. How are we investing in those? And you want to be on the positive side of the balance sheet on both of those axes. You've got to be profitable, because otherwise you won't be there very long. But equally, you should be beneficial. So trying to find that green area where you are on the positive side of the balance sheet in both cases. So as we develop our business cases and our investment plans, we use frameworks like the UN Sustainable Development Goals, right? And so we've measured how many of these goals are we actually having any kind of impact on. Just counting up projects in this graph. But you see, actually, there's the things that we do actually do speak to quite a lot of those agendas. Partly because we can get into those areas of the user base which other technical solutions don't get to. So if you're talking about international development, for example, there's a lot we can do, even when there is no infrastructure on the ground, but you can still offer services to people, right? So there's a lot we do around health, particularly telemedicine, remote healthcare delivery. There's a lot we can do in city management, city planning. There's a lot we can do in supply chain management. There's a lot we can do in food supply chain, particularly in agriculture, and climate solutions. Energy, sustainability, supporting sustainable energy. So it can bring these satellites into all of those areas of the agenda and have a beneficial impact on how they're progressing. Given that the EU is making a strong kind of stimulus investment post-COVID in all of this, and as part of their new funding cycle, I kind of asked my team to look back and categorise what have we done which kind of matches up with the EU's green agenda, which is a useful framework for us, but actually it's not so different from anybody else's green agenda. And we put together a report against their categories of sustainability impact. This is just a few months ago we did this. So this is the EU's categorization of what a green deal, a green stimulus breaks down into. And you see some of those same areas we've been talking about: transport and food and industry and energy and so on. By working as we do with partners who have a good understanding in each of those areas, and kind of look to you at this moment to see whether you are potential partners yourselves. People who come to us who represent the user communities, we can get the technical capabilities of space into use into all of those areas. So these are some of the people that we partner with in some of those environmental issues, and you'll see there's a lot of energy industry people in there, for example, a lot of supply chain management people and so on. And that turns into projects, and we typically 50% fund the projects through their R&D and product development stages, and help the companies to get them to market. And we pretty much hit every part of the agenda, right? So we hit all of that sustainability agenda. And here I'm talking about 80 million euros of investment over the past 5 or 6 years that we've put into these kind of agendas. So it's not peanuts, right? Each of the projects is $500,000 to $1 million. So we're talking about 90 projects here. So I think we can use this technology in a beneficial way, in a profitable way. The whole thing is kind of new. It's been around 5 or 10 years, this kind of commercial ecosystem, and it's building very strongly. Building very strongly in the Harwell campus, which is helpful in the Thames Valley. This is part of my team from all across Europe. They're all waving their national flags of the places that they represent, those dots on the map. And you can see I'm quite proud of the fact that it's compared to most of the space industry is quite institutional and quite quite careful kind of engineering community, and it's a lot of kind of grey-haired white men like me. I'm quite pleased that my team doesn't look like that. And is a lot younger and a lot more energetic and a lot more, kind of digitally native. And we're bringing a little bit of that energy then into the space industry, driving a little bit of a culture shift in the space industry so that it becomes more relevant to a commercial and a beneficial outcome. So that's what we do. That's where you find us, particularly if you have any interest in working with us. And I do encourage you, if you're working in any industry that might benefit from this, do kind of reach out to us and do some stuff. Let us do some stuff together. And I will stop there, and maybe we can have a bit of a chat about it. So thanks, Sarah, very much for the invitation. I'm really pleased to now have the opportunity to talk to you all. Sorry, you're muted.
Sorry, I'm mute.
I should have that off pat by now, shouldn't I? Really, you're on mute button. Thank you so much for that, Nick. I haven't seen any questions come up, but I do have a couple of my own, and actually I can see one of my colleagues, Adrian, who's joined us this morning, and you did a particular piece around 5G telecoms, which I know is his kind of his area. So I wonder if Adrian wants to have any word on that.
Good morning, Sarah and Nick. Indeed, welcome everybody. Nick, can I just firstly congratulate you on a terrific presentation, and it covered off so much, but the energy behind it all I think will be pretty obvious for most to see. And thank you also for sharing so warmly the invite for people to lean in further to the conversation. So while maybe the chat box may be a little bit quiet this morning, it's more, I'd say, probably a stunned silence on part of attendees, because it's not every day of the week you get somebody saying, look, we're doing X, we're doing Y, but we need you to complete the Z part of the equation. So that's just fantastic. And thanks to Sarah, obviously, for putting on today as well. In terms of the 5G component, for sure, obviously that's seen as a huge boon, probably to the post-COVID challenges economically. Probably from your perspective, and I know that what Sarah's alluding to, we had a very energetic roundtable just a short while back, and some significant players leaning into that conversation. We're seeing lots of dollars obviously bouncing around globally with regards to licenses. One wonders whether or not people are overpaying for some of those licenses, and are we revisiting some of the pain points of 3G and 4G previously? One would hope not, and if we are, we're probably going to be 10 years before we see some of that pain anyway. But the commercialization of 5G as a tool for business transformation is seen as a huge opportunity. What are your views from the early insights that you're seeing? And you're probably already ahead of the curve on this anyway, because obviously you're at the forefront of that technology, but probably seeing some of those commercial opportunities that others have yet to see and experience. But business transformation, as opposed to just another wave of technology, is seen as a huge enabler to future economic growth, near term, medium, and indeed long term. What are your thoughts and what you've seen around that to date?
Right. Well, firstly, thanks for the kind words. That's appreciated. Yes, absolutely. It's and of course the satellite industry has kind of presented its wares for each of these generations of mobile technology as it's come along, and I have to say it hasn't always landed. So the cash cow for the satellite telecoms industry historically has been television. It's been broadcast. That's where most of the revenues have come into the industry from. That actually is tailing off now, because people's broadband connections to their homes are better, and they've moved to this kind of streaming way of watching, as Netflix and YouTube now, rather than watching the football and the cricket being broadcast. Right? So there's a bit of a revenue shift away from the satellite industry in that kind of television part of the sector. Satellite has struggled in the past to get established in the broadband industry itself, in the data connections, to really establish its business added value. But I think with 5G, I think we have an opportunity in this. But 5G is not so much then just about what's on your mobile phone handset. A lot of it is about actually it's automated systems, right? It's machines reporting their status and being connected to one another. And there's a lot of very broad-based data transfers which are happening we talk about the Internet of Things as kind of the main application of this. So I guess to answer your question, your challenge, what's going to be the profitability of this, and how does this all then turn into a this kind of self-sustaining business ecosystem? It very much depends on what that automation, what the business case around that is. How much money is going to be in self-driving cars? How much money is going to be in city management? How much money is going to be in factory management? How much money is going to be in smart farming? These kind of end-use industries are going to be where the revenue is going to come from. And they will justify why you invest in telecommunications, why you invest in connectivity in order to service those uses. And if they generate enough money from the customer, and then it will all be okay. And satellite will have a role in that. Because, as I say, there are particular advantages that satellite has when you're dealing with things which are moving around or in the remote locations and so on. If you want coverage, then satellite certainly has a role to play within that. So it's not the consumer broadband market, which is particularly interesting, and it's not the TV market anymore, although it's still making good money out of that. The new market is this automation, and it's this machine-to-machine communication, and very much so we're very interested in anything we can do to stimulate the emergence of that customer base, because that's what's going to support everybody in going forwards.
That's fantastic. Thank you. Just as a follow-on, if I may, sorry, if that's okay with you. Yeah.
2 seconds, because I have queues of questions coming up now.
Okay. well, maybe I'm going to steal somebody's thunder, but just to say to you, I was obviously very encouraged to see the demographic, and you touched on it just in the last slide, Nick. Yeah. Women in STEM is obviously a very hot topic at the moment, and what are your thoughts as to where that is at the moment, and obviously the opportunities for further development?
I'm actually quite encouraged. As I say, that if you will, the heritage industry, no disrespect to my colleagues, but they all look like me, right? And they're engineers who've been around 30 years building spacecraft, who come from a certain subsector of the demographic. Because this is now opening up, and it's becoming very much more a game that anyone can play, as I was saying, because the costs have come down and because more people are entering the market. It's looking much more now like the digital economy. And so the demographics of the space industry is starting to look more like the demographics of the digital economy, which is much more inclusive. It's still not inclusive enough. And I have been involved in a charity, the Good Things Foundation, from the Tinder Foundation. I don't know if you've come across them. This is very much about digital skills. So there's still around 10 to 15% of the UK population even who don't have sufficient digital skills even to use the internet. And if you don't have those skills, you can't even apply for a job. You can't do anything. You can't get your benefits and interact with the government. You're completely excluded from society. So there's still, and part of the reason for that is that the people who are designing the web are not from that demographic. They do have those skills, and they've got a blind spot about the whole thing. So there's still some work to do to close that gap, to make sure that things are designed in such an accessible way that everybody, you don't need such a high level of skills just to operate the web. So we're in that milieu. I'm not sure that we have any particular distinguishing capabilities to make that easier, but I think we have to be very conscious of it. And particularly one of the things that we will be doing with the satellites is we're connecting people who are otherwise not connected. Right? You actually get the physical, you get the radio connection to somebody who otherwise has got no way of connecting to the internet. So, okay, that's great. You're making an internet connection to them. If they don't know how to use it, you haven't helped. So there's whenever we talk about these digital transformations or we talk about connectivity rollouts, we should at the same time be talking about the user skills. To make sure that people are equipped to be able to interact with the things you're presenting for them. And I think there's still a lot more that needs to be done on this. I don't think we're doing enough yet. We're starting to reach out now more into the schools to try to get people involved earlier. There's a great thing we do with the UK Space Agency, which started out as a kind of a Dragon's Den schools competition, and you'll see through this summer we'll be all over Blue Peter if you've got kids, right? So watch out for it in Blue Peter. It's competition with the kids. Who's got the greatest idea for using satellites? And you know what? We can actually probably help that to happen if you're 15 or 16 years old, because we've got all of the infrastructure to actually get a satellite up there. So we're trying to reach out to the younger community as well and get them involved early. And then, you have less of the problems with the demographics. Sorry, I talked on for quite a long time, and it's just other people here.
That's
Fantastic.
fine. Thank you, Nick, and thanks, Adrian, for your input. Before we go on to the chat box, I know Tony Bellis from 3M, if you're there, Tony, somewhere. I can't see you. There we go. I know Tony has a question.
Hello. Yeah, if I'm not abusing your goodwill, Sarah, I've got 3 questions, if you don't mind. 2 of them are quite easy. Quick one, easy one. Is ESA part of, is it part of any sort of EU construct, I guess, was one question. Then,
question, yes.
It is it? Okay, right.
No, I'll come back to it, yeah.
All right, okay. Then, I mean, we're a material science company. What I'm really interested in is the sort of trend in materials for these satellites, in the sense that, it doesn't strike me as, sensitive electronic equipment, sticking it on a rocket and then firing it into orbit doesn't feel like a desperately benign way to treat a very expensive toy. So I'm interested in the sort of trends in materials for these things. And I guess finally, I'm interested in autonomous vehicles. Level 5 autonomy is a long way away, and we're likely to have, levels of autonomy defined by the roads rather than the cars. But, to what extent is satellite technology vital to getting to level 5 autonomy? And what's the fail-safe if your satellite gets zapped or falls out of the sky? What happens? What's the fail-safe, I guess, is the question.
Okay, right, 3 questions. Let me go. Let me answer the political one then. So we're an intergovernmental organisation. So actually, it's a separate treaty between the individual governments, completely independent of the EU, that established ESA in the 70s. So the short answer is no, we're not an EU organisation, and UK is not exiting ESA as a result of Brexit. We do have do a lot of work for the European Commission as a customer, as a client, because we're a specialist agency. We have the engineering expertise that they don't have. But the EU is very interested in space and wants to invest into it. So they say, okay, what we really want is a satellite navigation fleet which is sovereign, autonomous in Europe. Because otherwise we're dependent on the GPS system, which is American. Actually, it's American Department of Defense. So you know what? Europe needs to have its own one. We're going to call it Galileo. And ESA, would you take care of getting that built for us, please? So that's kind of how the relationship works. So the money might come from the European Union, or European Commission, comes to ESA. We do the contracting, and we work with industry to get the thing built on their behalf. That's about 25% of what ESA does. The rest of it, we work directly with the individual countries according to whatever their priorities are. So UK comes to us with their agenda and says, would you invest on these things and these things in our behalf? And that relationship doesn't go via Brussels at all. So there's still plenty to do. And in the UK context right now, UK is now saying, actually, you know what, we need sovereign capabilities for UK now, because we need to be independent from the EU's capabilities. So what happened between Europe and the US is now happening between UK and Europe to say, well, actually, UK needs to build its own stuff. So actually, there's quite a big push for additional capabilities. You'll see space launch capabilities, both rockets and launch airports. You'll see satellite building. and satellite operations, and the whole ecosystem being built as a national sovereign capability. So there's an awful lot going on in the UK at the moment. Now the materials question, yes, there are particular requirements on materials for anything you're going to send to space. It needs to be radiation hard, is one of the big ones, so which particularly affects the electronics. Because as soon as you're outside the atmosphere, then you're exposed to quite a harsh environment from a radiation point of view. Lightweighting, strength of materials and lightweighting of materials, it's very expensive to take things to orbit per mass. So if you can make them lighter, that's very beneficial, right? It cuts the costs down. And you mentioned vibration. Absolutely. There's a test rig in our technical center in Amsterdam, which will take your entire spacecraft, and they're not all the size of bread bins, right? Some of them are the size of buses. And it just expose your spacecraft to the kind of environment it's going to see during launch and then in orbit, which includes things like shake it up and down and see if anything falls off, right? This is a really quite impressive facility we have there. We've got a spacecraft which is going into solar orbit and going to go and have a look at Mercury. 2 spacecraft. They're going to have to deal with an even harsher environment as they come close to the sun. So we have a big vacuum chamber with massive heating elements at one end of it. Big projection lamps, which expose it to the kind of radiation flux that you'll get when you're close to the sun to make sure nothing melts. So yeah, absolutely. So anything to do with resilience against harsh environments, and anything to do with lightweighting is relevant for space, and we're willing to pay a premium for that. Yeah. So for things like solar panel development, which is absolutely core technology, because that's how all the satellites and spacecraft are powered, we're willing to pay the extra premium for the performance, the extra efficiency that you wouldn't pay for a domestic installation, right? Because the cost-benefit calculation is different there. So it's a bit like defence procurement, where actually you will pay for the best stuff because we're in low volumes and we need the performance on it. On autonomous vehicles, briefly on that, yes, the satellite connections, particularly if you're dealing with geostationary satellites, so the ones where you have a fixed antenna because the thing is always the same place in the sky, there's about a half-second round-trip delay on this signal out and back, and then return signal out and back. That's not quick enough for vehicle-to-vehicle communication if you're trying to do something like collision avoidance. So one solution to that is to have satellites which are a lot lower in the sky. So low Earth orbit is filling up with satellites about 400 kilometers up. So then it's a much faster data transfer. It's still not really quick enough for collision avoidance, but it's certainly quick enough for things like vehicle to infrastructure communication, keeping your car on the road. It's quick enough for that. And it's certainly quick enough for any kind of situational awareness. There's a traffic jam up at front, or this is what the weather's going to be like, or those kind of information systems which are useful in the vehicle autonomy. So that's more the kind of stuff that we're talking about. The stuff which is on board the vehicle, the radar and sonar systems which are stopping them from crashing into other vehicles, they're probably not routing that via satellite. But we are very worried, or have to be very cognizant of anything which, if you are in a safety critical situation, anything that could take the system out. There's a new spacecraft going up called Lagrange. Again, UK invested very heavily in this, which is to look at space weather, look at solar flares. That's the kind of thing that could knock a satellite out of operation, is if there's a big solar flare. So we'd take another spacecraft, we'd park it a sixth of the way back around the Earth's orbit, so that it can look sideways on at the space between the sun and the Earth, and watch the solar flares coming towards the Earth, and send us a quick signal saying, sorry, you might want to just check your systems now because there's something coming your way. So this space weather is one of the things that we have to be concerned about. And just too many satellites in orbit colliding with each other is one of the things we have to now start worrying about. So many people are putting things up. I see there's a question in the chat. Maybe I'll go straight onto that. How many satellites are up there? 5 years ago, there's about 1,000, 1,500 satellites up there operating. Mixture of commercial ones and kind of government military ones. Now we're launching them by the 100. Each launch puts another couple hundred. You see what SpaceX are doing. talking about this kind of 400 kilometer up low Earth orbit range, where the satellites are kind of close to the atmosphere. You need lots of satellites to populate that orbit slot. You can't just park one satellite a long way away and it sees half the world. If you're that close in, you need many satellites so that you can always be connected to them. So now we're putting up fleets of satellites with hundreds or even thousands of satellites in the fleets. So those numbers are climbing very steeply, lots and lots of very small satellites. And it's rapidly rising up through the thousands. So it's a very great concern now that all of those satellites, even though space is relatively big, if you're just taking a thin shell of space, which is 100 kilometers thick, and you put a few thousand satellites in it, all in different orbits, all crossing each other, air traffic control in space is becoming quite a thing. And there's a lot of work now going on to make sure that any satellite which is dying of old age, we have the ability to go up there, grab it, and get it out of the shipping lanes. We're putting a legal responsibility on people to say you have to deorbit, you have to take your satellite out of the way at the end of its planned life. Cleanup operations. The trouble is everything's moving at 17,000 miles an hour. So catching anything which is a hazard to shipping is actually quite a challenge on its own. But there's quite a lot of a space safety in space concern that we have at the moment. It's getting quite overcrowded up there in this low orbit slot. Sarah, what else do we have in the chat?
Unmute again. So Sam Goodsell asked a question. Could you enlighten us on some of the startup businesses that have been supported? Perhaps an overview of what they're doing.
Yeah.
The more I hear on the topic, the more scope expands.
Okay, yeah. And so I'll talk about maybe a few of the examples of in the UK ones. So let's start with Open Cosmos, who are still on the Harwell campus, but came through our business incubator. So they build the little satellites. And so they'll build to order a satellite, this kind of size thing, with whatever bit of electronics you want to put on it, you put a camera on it or whatever it is, right? And so they'll build that for you and they'll get it launched for you and they'll operate it for you. So they provide that kind of service to take things to space. So that was a startup company that came through our business incubator and said, we think we can do this. And now they have about 50 people or so next to us, and they're offering this as a service to the space community, and indeed to the non-space community who don't have the skills to otherwise get into space. So they're part of this transition. Another example would be Resatech, quite a different kind of thing. This is an Earth observation, cameras looking down, looking at forestry. It's one of the main applications that we have with them. Count all the trees, look at their health. So if you are doing something like land management, forestry management, you can go to them. They will do all of the satellite imaging, including in the infrared and whatever else might be useful. They'll analyze those images and they will tell you what's happening on the ground in your forest. We have companies working with drones. A lot of stuff going on. There's good interplay between satellites and drones, where you can fly the drone around just above the ground and get one form of data. You have the satellite further up giving you a different kind of data, and the satellite also is talking to the drone about its navigation. We have a number of companies working on this. There are things which have spun out from the space program. There's a company who's in there at the moment who's taking some of the technology from the Mars rovers. Sorry, you mentioned the Mars rovers. Take some of that technology and use it for a little rover which is going to run around in chicken farms and count the chickens and collect their eggs and do all that very kind of mundane compared to Perseverance driving around on Mars. But we can transfer technologies back from space back into applications on the ground. So any idea that a startup might have which somehow has some connection to building something in space, to using something in space, to adapting something from space back onto the ground. I mean, we'll support startups in all of those areas, and we do support startups in all of those areas. So it's really very diverse. I mean, I say there's 1,000 of these startups on our books. I can't do them justice. You know.
I suppose my actual personal question would sort of tag on to the end of that. You mentioned, sending experiments into space, or the people that you're working with, who is the ideal company to put an idea forward to you? Could it be literally anything?
Yeah, literally anything, literally anybody. I particularly like to see SMEs who maybe are established, doing something maybe in the digital economy already, and say, actually, you know what, I can augment that by bringing some space capability into the service which is already there. Why do we like that? Because small companies have energy, and when you take on new things and grow with them. But if you're a little bit established, then you already have a footprint into the market. That means we're not starting from a clean sheet of paper, and we can get some impact sooner. So that's really the sweet spot. But equally, as I say, we work back at the startup end to try to feed more companies in who are natives into this community right from the start, and we're always interested in anybody who's got an idea and wants to start up a new company. And we're interested in any kind of corporate organization which can be a prime and can be an anchor into the markets. And there we will work directly, and we'll make these partnerships. And we just kind of go, okay, so you already understand this market much better than we possibly can. Tell us what the market needs, and then maybe we'll go and find some SMEs who can supply to the corporate. Okay. So we're trying to work all across the spectrum of companies. About 80% of the funding that we put out, and I signed checks last year for 70 million euros into 200 SMEs. That's about 85% of it is into that SME part of the community. Yeah.
That's actually very interesting, and actually it was reflected, I think, on the news. Some news bulletin earlier this week, where they said that the most profitable companies eventually actually started out with a purpose. So it wasn't to become multimillionaire. The directors weren't there to become multimillionaires. What they wanted was to fill a gap in the market, or they had a purpose, a kind of solution, and that apparently makes the most successful companies. So that kind of fed into what you mentioned earlier. There is another question. Alan and Sam are doing well on the question so far. So what entity regulates the safety and integrity of commercial satellites, and have there been instances of injury or serious damage being caused when they've fallen back to Earth? Well, didn't we have a bit of a comet fell to Earth the other day, didn't it, in Gloucestershire?
Yeah. That wasn't one of ours. Just some random bit of space rock which happened to punch through the atmosphere and land in Gloucestershire. Yes, and they're picking it up off people's driveways because the scientists are really, they love to see samples of this stuff. Generally, when things fall back to Earth, it's done in a very controlled way. They still have enough propellant and enough control that you land them where you want to land them. And where you want to land them is in the middle of the Pacific, in which case it's not a problem, right? So there's a graveyard of dead spacecraft in the deepest part of the middle of the Pacific. Now, there have been a few cases where it's been a little bit alarming. There was a Chinese space station, this is about 2-3 years ago, so not just a satellite, but a whole habitable environment. So quite a big thing. And they were losing control of it as they were trying to deorbit it, and there was a fair chance it was going to miss the Pacific and hit South America, and going to land in Chile or somewhere. So everybody was like, but it was fine. It was fine. It landed far enough off the coast that it was all right. But yeah, you're right. There is there is that risk. Okay, I mean, we're talking about 1,000 or so, some thousands of these things, most of which are small enough that they largely burn up anyway on the way down. But as the numbers go up, it is one of the things we need to worry about, is make sure that we can deorbit things safely. So this is why I'm saying we're investing in specialist space missions to be able to go and grab anything which we don't have full control over, so that you can take over control of an ailing satellite. And deorbit it in a controlled way. As far as regulations go, it's it's a bit of a mixture. We're still lacking in international, in global regulatory environment for this. For some areas like spectrum licensing, we do have that, and the ITU, the International Telecommunications Union, takes care of that. But for the most part, it depends where you launch from and whose jurisdiction you launch from. It's a bit like the maritime industry, whose flag are you flying, and they take care of regulating your flight. So you get a license from the place where you're going to launch from. And then they impose rules which are, they're more or less homogenized around the world, but not completely, on what you have to comply to. And the most important part of that is you stay in your lane. Now, you fly where you're supposed to fly, and you don't go flying somewhere else. In a lot of cases, it's the aviation authorities, right? So it's that responsibility has been with the UK Space Agency. In the UK, it's just being handed over to the CAA now. In the US, it's the Federal Aviation Authority. So it's those kind of authorities who license and regulate this stuff. There isn't an overarching global authority for it for the moment.
Thank you. So no space police then?
No space police. We keep hearing about space forces. With,
last one then from Sam again, please. Read the overcrowding issue. Are all satellites different, or do you look to see if the service is available on an existing satellite? In future, I assume consolidation will occur.
Yeah, and particularly see this with the Earth observation satellites, so the ones with cameras and sensors on them. There is a lot of risk of duplication. I mean, a camera's a camera. Sometimes you get ones with a higher spectral range or particular sensors, things like this, and they have a differentiated place in the market. But if it is just a camera on a satellite, then you know what, they are all they're all a little bit commodity. It's not really a proprietary differentiation necessarily between them. So there is, I think that it's likely that there will be some consolidation in the industry, where some larger organization will start buying up these small companies who've launched a few satellites each, and you'll end up building fleets out of things that you've purchased from many people who've launched them independently. Now, who it is who's going to do that consolidation? Amazon have a great interest in this. They may be the ones. Because they would quite like to control this bit of the internet, and have those data flows. And certainly they're building the cloud data processing software to be able to take the image data and provide big repositories of all the images which come from different satellites. I think it's a natural extension for them to say, you know what, Amazon's going to own the satellites as well. And so somebody like that might start buying all of these companies. Hasn't happened yet, but you can kind of see it on the horizon. Equally, the AI companies who are involved in the data processing and the image processing, those kind of people who bring that kind of data into end users. For the moment, though, we have a lot of independent companies who each are specialized somewhere towards an end use. So they're close to the customers, and they've tailored their proposition towards those customers. Whether it's agriculture or transport or whatever it is, and so they're specialised towards that. But I can kind of, I think the question is well posed. I think there is the possibility to unify a lot of that. In terms of navigation, we don't have a lot of independent navigation fleets. I mean, those are still, they're relatively few. And telecom similarly, it tends to be an infrastructure where you need a large scale investment, even if it's lots of satellites right from the start. But the ones which are about images, yes, yeah.
Interesting. So if we had somebody around the table here, or if I happened to find £1 million down the back of my sofa and wanted to launch my own satellite, do I then come to ESA and say, hey, look, this is what I want to do? Mm-hmm. Are you a factor, if you like, and able to say, actually, there's somebody already doing that, you can pay them a fee to run the same experiment or whatever, or do I have to buy my own bread bin?
So you don't have to learn how to build satellites. That's part of the transformation which is going on now. So there are companies, I talked about Open Cosmos, Surrey Satellites if you want something a bit bigger down the road, Clyde Space in Glasgow. There's quite a few companies out there now who will build satellites to orbit or equip satellites to orbit based on a standard build that they have. So you don't need to start from scratch. So if you come to us with a proposition like that, we're likely to say, that's great. Have you got something in the payload of the satellite, in its kind of technical core that you're going to develop? In which case, we'll help you to develop that, and then we'll introduce you to somebody who can get it into space for you. So you don't have to become a satellite building company, but you can become a camera building company.
Yeah.
Who makes a partnership with a satellite building company. And we certainly would be willing to support that, particularly if we can see the business case of well, who wants the images from that camera, who are those customers, and how are you going to make those connections. That's the stuff we're really interested in helping people with.
So it's the end use. I will take the last question before we hand over to my closing part, which won't be nearly as interesting, from Yola. Welcome, Yola. And she's asking, with sending all the satellites, how are we going to keep them from colliding with each other, which is a good practical question, or with some other space rubbish? Aren't we making the space around Earth very messy?
Yes, we are. And it's So how the answer to how is we need to know where everything is, which is potentially hazardous. Right. So everything is being tracked by radar. Big radar installations looking up and just saying, well, hang on, so they're going over there and they're going over there, and in 8 hours they're going to cross within 100 meters from each other, and they send an alert to the operators of both of those satellites and say, you're on a collision course, guys. The resolution of our radar can't tell, it says there's an 8% chance you're going to hit each other. Take some evasive action. Right? But we had a case last year, a satellite we just newly minted, an ESA satellite with lasers on it, which was going to measure wind speeds, AOLAS. Lovely thing, very good for meteorology and also for climate science. Institutionally funded, kind of government funded satellite to do this. Brand shiny new, barely switched, barely come out of the plastic peanuts out of its wrapping. And then one of SpaceX's satellites was one of these, gave one of these warnings to say, you're 8 hours away from running into each other. We just spent 200 million on this satellite. They'd spent maybe 10 million on theirs, and they just went, yeah, well, we can afford to lose one. You move yours. And so we had to take the evasive action to get out of the way of the SpaceX small satellite, which was coming through. But at least we had the alert, right? So we had the tracking system, which allows us to do that. And that kind of management is going on all the time. And as I say, if there's anything which somebody has lost control of, then we have to go get it. Right? And we have to go do something about that. The hope is that we never lose control of any of these. And we're putting responsibility on anybody who's launching to say, you must not lose control of your satellite. That's a real problem. I think there's a role, for example, in the insurance industry in this, to say you're uninsurable if you develop a track record of this kind of misbehavior. So one of the industries we're trying to reach out to is the insurance industry. Say, can you help us with this? Can you drive some responsible behavior in the industry?
That's really interesting, and I can only imagine what those kind of premiums might be to ensure against, or to mitigate against those kind of disasters. Well,
and we lose a couple of % of things on the launch pad. That's kind of normal.
Yeah.
Not every rocket succeeds, and that's but that's quite a quantifiable, quite an insurable risk. That every now and again you'll be unlucky and you'll put your satellite on board a rocket which blows up. It happens.
Okay.
Maybe one time in 50. Less than that, by the way, for human space flight, right? So just in case anybody's going into the space tourism, but still not nothing.
No.
But yeah, that's an insurance risk, but it's an insurable risk, and you can buy a policy for that.
Great stuff. Nick, you've spoken so eloquently. I can only thank you. I could sit here and listen to you talk all day, as I'm sure that our audience could as well. We've had some great questions, and for sure Sarah will be having to do very little editing, so we'll share this on the YouTube channel. But for now, I'm just going to say thank you. My mind is officially blown. I had loads more questions, although many people actually echoed what what my questions were, but I'm fairly certain to our delegates, if you want to get in touch either with me, and I can pass your questions on to Nick if anything occurs, or you can find him on LinkedIn quite easily. So thank you again, Nick.
I had great fun.
Good, good. I'll ask Sarah, if you don't mind, to put my last slide up now, just to tell you what's happening. So also, again, on a kind of green theme, but if Tony's still around, this might be one for you as well. So I've got Martin Afire, who, I don't know if anybody or any of our audience are familiar with, England rugby player, but what drove him to become a brand ambassador for Connected Curb, who are an electric vehicle company. They don't make the vehicles, but they're championing electrification for all. So particularly millennials who might live in flats or don't have off-street parking, for instance. They've undertaken polls to say many millennials would actually choose an electric vehicle. However, charging is an issue. So we're going to be looking at subjects around that. So I'll be delighted to see you all there. Drop me a line if you want to know more about it. There is, of course, more on the website. That's 14th of April, but drop me an email and I can book you on. Thank you to our wonderful audience today. Thank you for again to Nick, and do keep in touch. That's it, over and out from me. We finished a little early. Thank you so much, Nick. I'll speak to you very soon.
Thank you. Thanks everybody. Thanks for the questions. You're a good audience. It's a pleasure to meet you. Maybe in person next time.
Yes, that would be lovely. Thank you so much.
Good.
Take care.